Okay, today we're talking about direct variation. My doodle notes aren't popping up on my screen, so I'm just going to write them with this. The first thing we need to know is the equation for y. And in direct variation, y is going to equal kx. K is going to be that constant of variation or constant of proportionality. So I know there's a box down at the bottom that says, or at the bottom of this box that says that. And that's true so long as k is not equal to 0. Can never be 0. So finding the constant of proportionality if they give you 2 points. What else have we found given 2 points so far? Right, the slope of a line. And our equation for that is y2 minus y1 over x2 minus x1. We're doing that same thing here. So I would take 0 minus 4 over 0 minus that negative 1. When I have those two negative signs together, they become a plus. So I get negative 4 over positive 1, which just simplifies to negative 4. And that is my constant of variation. Okay? Try B on your own. Okay, so if I wanted to graph a direct variation, and I have this equation y equals negative 6x, where negative 6 is that k value. Notice that is my slope. That's the same thing as that slope. I don't have that y-intercept, so I'm going to start at the origin, 0, 0. And then I would go down 6 over 1. 6 over 1, graph a point. Or I can go up 6 and left 1, because left is a negative direction. And of course, I draw my line through those points. Ooh, not great line. Oh well. And I write the equation for that. Okay, so that's how I would graph a direct variation. Looking at that graph, let's answer a few questions. Well, we know our equation is what? Good, y equals kx. That we found out above. We know that y equals kx will always pass through one point, and it's a point that we will always pass through if there is no y-intercept. So take a guess at what that point might be. Good, the origin. And if you didn't know, the origin is 0, 0. And y equals kx illustrates a constant rate of change. I forgot to put that one on here. A constant rate of change, so to fill that part in. And now let's talk about that slope. And looking at that last one, when k was a negative value, negative 6, my slope was negative. So my slope is negative if k is less than 0, or a negative number. My slope will be positive if k is greater than 0. So the fifth box on your page says, suppose y varies directly with x when y equals 72 and x equals 8. So I'm going to start with that equation, y equals kx. And I'm trying to find what k is when y is 72 and x is 8. So all I'm doing is solving for k. Now this looks pretty easy. To solve for k, I divide both sides by 8, so I get k equals 9. Okay? All it is saying if it varies directly, so you know that equation for direct variation is y equals kx. Here's some starting points, 8 and 72. Plug them in to solve for k. Why is this useful? Well, in the last box, we're going to have to recall what that k equals. So if you will, it says using the direct variation, so which we found in the last example, so that k equals, what was it? Good, 9. Find x when y is 63. So I want to start with that basic equation, that y equals kx. We know from the last example k is 9, so we can say y equals 9x. And we want to find x when y equals 63. So I'm going to plug in 63 for y. And then I'm going to solve for x. So go ahead and tell me what x equals. Good, x equals 7. Thanks for watching.